Hi, Simon Holland here. Just letting you know that this is part B of a two-part series with Dr. Tracey Sutton. This part will return you to the free-flowing conversation style that you know and love. If you missed part A, please check it out on your iTunes or BeyondPod, as Dr. Sutton goes through and examines mysterious beasts of the deep, hauled up by a Russian deep-sea fisherman and posted on his Twitter account. Without further ado, part B of this two-part series.
Our planet Earth. A world of mystery and imagination, science and wonder that is constantly being gazed upon and unraveled by the finest minds humanity has to offer. Welcome to the UNIVI podcast, the show that presents a free-flowing conversation with those beings at the very center of the world of academia and research from all around the globe, with your host, Simon Holland.
Hello and welcome to episode 10 of the UNIVI podcast. I'm your host, Simon Holland. On this episode, we chat about the weird and mysterious creatures of the sea with Dr. Tracey Sutton, who is an associate professor at the Oceanographic Center in the College of Oceanography at Nova Southeastern University. Dr. Sutton's research focuses on the ecology of the marine systems, particularly those from the open ocean, with emphasis on the fauna and ecology of the deep-pelagic zone by combining observational, organismal, and theoretical approaches to help understand the Earth's largest but least known ecosystems. He has worked with organisations such as NOAA and the BBC in consulting roles, and is the principal investigator and consortium director of DEEPEN, an intensive multidisciplinary collaboration to oceanic discovery and management based in the Gulf of Mexico. It is said that we know more about the far reaches of space than we do our own oceans. Is that a true statement?
Yes, absolutely true. We have super high resolution maps of the moon, for example, and yet we've only mapped maybe 5% of the ocean floor, and this midwater stuff that we're talking about, we've sampled way less than 1%.
What are some of the? Have you seen? First of all, what got you into this field of research?
Well, so I've pretty much always known I wanted to work on fish. Ever since I was 6 years old and went to the beach and saw some fish, I pretty much knew that that's what I was going to do. So then it became a question of what. And in graduate school, I went on my first deep sea cruise. And as soon as I saw that the tray full of black dragonfish and blue lanternfish and bright red shrimp, I knew that, that was it. I was hooked. So mostly the thing that I'm most interested is that it truly is still exploration. So in most places, it's highly unlikely we will find any more new fish species in shallow water, because it's, we have a lot of surveys everywhere. Everybody surveys the coastal ocean. So there might be a few spots where there's packets of unknown species, but it's fairly rare. Whereas in the deep sea, you can literally catch a new species on every single research cruise.
Is that part of the attraction that's definitely the attraction for science enthusiasts, that you're solving the mysteries here. Is that part of, do you feel like you're in a field of science where you're sort of pushing the envelope on different fronts? Yeah,
it's basically a blessing and a curse. And that is, it's a blessing in that there's still so much that's new. There's so much diversity we don't know about, and the public at large really cares about that kind of thing. It's, exploration in science is, for most people, the most important contribution of science is the discovery of things. But it's kind of a curse in that we really want to know how the ocean works, and yet we're limited with data. We just don't have anywhere near the data for the deep sea as we do the coastal ocean. So there's so much we want to do that we can't do because we lack just the basic data, like how long does something live? We don't even know that for most of the things that live in the deep ocean. It's a very important piece of data. To understand an ecosystem, you have to know how often species replace themselves. And if we don't know that, then, we're limited.
Is there anything that looking at the ecosystem and the way they're linked together, is there anything that you think, humans are changing or the environment's changing that we're going to lose from that kind of? Are they delicate ecosystems that we're dealing with?
Yeah, absolutely. So the deep ocean, because it's so stable, the deep ocean doesn't have, hurricanes or floods or whatever. The deep ocean is nice and stable, same temperature, very, very old. So the animals that live in the deep ocean are just not equipped for change, especially rapid change. But now we have the technology to exploit any part of the ocean we want to. There's no part of the ocean that's too deep for us to exploit. So, for example, in your neck of the woods, deep sea mining is going to become a huge next big topic. As we're building more and more computers and cell phones, we're running out of the elements that we need to make these things, these rare earth minerals. Land sources will be extinguished. So there's a big push afoot to mine the deep sea floor, which means for all intents and purposes, we're going to sterilize that seafloor for basically forever in terms of human existence. 1 million years it would take for it to repair itself. So I guess the point is that the deep sea ecosystems are not structured to be able to handle change, especially fast change. And we're now extending our reach into the deep sea in areas that we don't even have a proper inventory of what lives there yet. So we could literally lose things that we're not even aware existed. Actually, we're quite likely to lose things that we weren't even aware existed.
It seems like such a common thread in science that academics are trying to do research and trying to do works in area, and then the push for humanity to exploit something to feed a growing population will destroy things they haven't discovered yet. Is that a desperation that you kind of feel in your field and explorative biology as well?
It is, and if you really lose yourself into all of that, it can actually be fairly depressing, to be honest. But what we can do is do the best we can do. So right now, scientists often live in this bubble, which the ivory tower thing. So we go out and we do our science and we publish it in our science journals, and we think we're doing our job. So the main thing we can do more is actively engage the public in our research and why we need to do it as a way of justifying doing the science before we go and create an industry. And the irony of all this is science is very, very cheap relative to industry. We're a drop in their bucket, almost irrelevant.
Tell us a little bit about Deepend. It's one of the initiatives you got going, and how you guys kind of set yourself up working with Nova and Oceanography.
Sure. It actually follows exactly on what we're talking about. The birth of Deepend was actually Deepwater Horizon. So I did my master's in doctoral research in the Gulf of Mexico, looking at these animals that are deep in the water column. Mostly just trying to understand, food webs in the open ocean. And then I got away from that a little bit. I worked on sharks and worked on various other things. But after the Deepwater Horizon oil spill, NOAA, the American agency that's tasked with determining the damage from a large disaster, that was set up after Exxon Valdez. They set up a system where NOAA became the entity that would determine the severity of a damage to the environment. The problem for NOAA with Deepwater Horizon, again, we had no inventory of what lived in the deep Gulf of Mexico. So it became very problematic for them to assess the damage, because Deepwater Horizon, the wellhead, was 1.5 kilometers deep. So it was well into the bathypelagic zone where that white anglerfish lives, for example. So it was very, very deep, and all of that oil came up through the water column. So NOAA asked if I would design a program to survey the deep Gulf to find out what was there. So I did that, and we did that for about a solid year, and then we analyzed the samples for about 4 years and submitted all our information to NOAA, and they came out with their damage assessment for BP. Deep End is the follow-on project to all of that, where we're doing science that is not directly related to, say, a court case or anything like that. It's basically more pure science. So it's kind of the project I've always wanted to do in my whole career, and that was to join all sorts of different fields together to study the same problem. So we have physical oceanographers, we have people who study satellite data from space. We have biologists, we have geneticists, we have a chemist, and we're basically trying to build a picture of how the deep Gulf of Mexico works, because we're still trying to figure out what Deepwater Horizon did and may still be doing. We have no reason to think that the effect is over.
It feels like you're in the perfect storm of a rush to get things done before we mess it up, the area. There's so much to discover, and like you said, discovering things all at once, that you need to try and cast your net as wide as you can, but they're so different that you need to investigate each sort of specific adaptation and change and structure of each one of these creatures. Is that at times you just must be overwhelmed? Do you go to bed at night going, how am I going to do all this by myself?
Well, basically you just defined my last several years of existence. But it's a good problem on the one hand, because basically we want to do this work, and with funding cycles the way they are, you really have to go 110% into a project like this, because who knows, what the winds will bring in the future, especially with, our crazy new administration. We don't know what's going to happen. So, we're really going full bore on this, because in many ways, it's an important question, and who knows when we'll be able to do all of this again.
Tell us about do you get PhD students coming in? What's sort of some of the interesting things that they're studying that you're able to share?
Well, that's actually what I'm most proud of with Deep End, is that it provides a platform to train a new generation of scientists, because we are losing expertise in the deep sea, especially people that can identify anything. The whole field of taxonomy is rapidly disappearing. People just want to do other things. They want to, model things and do this, that, and the other. So we have a group of students who are working on the taxonomy of these various deep sea things. Everything down there needs more work. I mean, everything. So it's nice that we can support people that actually want to learn the fauna and learn what something is, such that in the future we'll have people that can identify things. That's not trivial at all. And we have students that are looking at food webs, and they're using some advanced chemical methods to not just look at what's in the stomach, but look at the composition of an animal's tissue to find out what it has been eating its entire life. So I think that's very exciting. We have geneticists that are learning new molecular tools to be able to identify species. In some cases, species look identical, and the molecular data say these are different species. They're as different as cats and dogs, and yet they look almost identical. So I'm fascinated by that. Then we have some students that are looking at the chemistry of the animal tissues to see if they still have fingerprints from Deepwater Horizon in their tissue. Like, is that oil still in the food web? Yeah, and we have some students looking at the satellite data to find out what the influence of the Mississippi River is on the deep Gulf of Mexico. So that's kind kind of a neat project, I think.
How does it connect into? How does the Mississippi River connect?
Well, most open oceans are beautiful blue clear water, and they're that way because there's not a lot of fertilizer in the water. It's everything's pretty much consumed as soon as any new fertilizer gets in there, it gets consumed by something. So you have nice clear, pretty water. The Gulf of Mexico is like that. It's a beautiful blue, clear water system, but occasionally the Mississippi River just dumps a whole lot of fresh water into the system. And for example, after Deepwater Horizon 2011 was a very, very wet year. So a lot of river water went out into the Gulf that carries a lot of phytoplankton and nutrients out into the Gulf. So these little pulses of fertilizer that go out there naturally, it's kind of a natural experiment. It's something that's pretty keen, but it also makes it hard to figure out if we see changes out there. Was it, say, from Deepwater Horizon, or was it just Mississippi River water? So it's a complexity that actually is a interesting natural experiment.
I want to talk a little bit about your website because it's such a fantastic resource for anyone that's interested to find more and to get a contact.
Oh, thank you.
Can we talk a little bit about your publication section? You've got a lot of stuff out there. Tell us a little bit about what you've been working on.
Yeah, actually, one of the projects that I've been working on is to create a map of the biodiversity of the deep-pelagic animals that live in the water column, to make a global map of the different communities throughout the world ocean. And it's kind of naturally it's a somewhat complicated thing, and we don't have enough data. But what we did was we got a whole group of experts from all over the world together for a workshop to find out what we all thought was the state of the global ocean. And the point was to provide a map that resource managers could use to help in conservation efforts. So, there's kind of this global goal of determining the diversity of the oceans, of the whole world. And right now our biggest question mark is still that big open ocean part. So I'm working with a group. We've got a manuscript in review now where we're making a map where we've divided the world ocean into these eco-regions, and then we described each of the eco-regions as to why it's unique and what's the story of each region. And the Gulf of Mexico turns out to be a unique region that's actually one of the most interesting of anywhere in the world.
Is there anywhere that you'd love to go? I mean, James Cameron went to the bottom of the Mariana Trench. Is that something that's on your radar, a trip down there, or what's the kind of dream that you have in a vacuum?
No, I would love to, but they're interested in looking at the bottom. I'm interested in looking at the water column on the way down, because we're always looking for the world's deepest fish. And right now we think it's a snail fish that was found at about 8,000 meters. But the Marianas Trench could have fish in it. They're always looking down. I'd be the one looking up.
I guess that's the thing, is you just don't know. You go, oh, what's that in the window? And then it's something brand new. And that's the new record, I guess.
Oh, absolutely. Yeah. There's sections of the world ocean that are particularly diverse. So the Gulf of Mexico is one, the South China Sea, the Tasman Sea, and on your side, they're just these little kind of bastions of high diversity that I think are fascinating, but they all need more work. I'd like to go somewhere warm and palm tree-y, because before the Gulf of Mexico, I was working in the North Atlantic, which was really, really cold, and I kept thinking, what's wrong with Fiji?
And now, is there any? I often see this kind of thing pop up. And is there any sort of discoveries that could change humanity in terms of application for medicine, or a type of, antifreeze or blood cell, the way the blood cells work, or anything that's popped up?
In a word, yes, absolutely. So one of the things I teach in my classes about biodiversity and why we care about it is that it's the raw material for evolution. So that's what I tell people that, like I was saying, each thing is a solution to a problem, but it's also the raw material for the next problem and the next solution. So, for example, we were looking at that rat trap fish, the one with the red eyes.
Yep.
The protein that it has in that photophore that makes red light would be incredibly useful if we could make that red protein. Because, for example, for cancer research, if you could introduce an antibody into a patient that was marked with that red protein, and the antibody could go and find, a growth of tumor cells or whatever, it would now be lit up. You could pass a laser through a human, would have no effect on the human. That wavelength goes through human tissue like it's not even there. And you can actually find tumors at just the microscopical size. You could just pass a laser along. It's kind of like Star Trek, that you just scan somebody with a tricorder, and then boom, you know where a tumor is. You could zap it with a laser with no surgery at all. So
you could do it at the airport.
Those are the kind of things. Pardon?
You do it at the airport. You get off the plane, you go through customs, boom, laser, take it aside. By the way,
they just scan you for
got
free.
cancer. Yeah.
Yeah, and people have been looking at deep sea sponges. There are some sponges that seem to have anti-cancer proteins in compounds. So yeah, there are the potential for a number of useful chemistries. It's kind of like the rainforest, where they often find drugs and pharmaceuticals in the rainforest. The deep sea is very much like that.
Okay, I'm going to hit you with some quick hits to while we finish up. Number one, do you still go fishing?
Oh, absolutely. Fish. Well, when I have time, I definitely fish.
I feel like you have an unfair advantage. Are you good? Do you catch stuff?
Well, I do okay.
Come on, you must have some the water here, the this there, the that, like this. You have an anglerfish you can attach, and you can turn its lure on and throw it in. And
well, I'll just say, I do pretty well. I have a very specific way of fishing, and I like to catch a large variety of things. So I always fish with lures, and I try to catch as many species on a trip as I can.
Okay. Bad habits of scientists on when you go out because you go out for a while at a time, right?
Yeah.
Yeah. So do you what's it like living with other people, or do you just kind of do you play Jenga at night time? What happens on these trips?
Well, that's a good point, because when you're out at sea for anywhere from 15 to 50 days, the farthest you can get away from somebody is 50 meters. So, you all have to kind of get along. And for us on our deep sea trawling cruises, we don't sleep. I mean, we work around the clock. So usually after about 7 to 10 days, people can get a little cranky. So the main thing is, play some music. If somebody's in a bad mood, just kind of keep your mouth shut and keep working, and then periodically stop and have a break and do something to kind of cheer everybody up. That's usually the key. And if anybody's getting cranky, you just kind of shut them down and isolate them so they don't rub off on anybody else.
So you got to kind of scout them out before. You're like, who's your favorite band? Miley Cyrus, get off. You're off. Are you like Iron Man?
Yep,
you're right.
Yep.
Great. Come on.
Well, we're very fortunate with Deep End in that, I was trying to be kind of careful about selecting the people that go out to sea. These are people I've known for quite some time. They were people I've gone out to sea with when I was a graduate student. So we're all friends, and we try to portray that with the graduate students too. That everybody you meet's a colleague, so be friends with everybody.
James Cameron is giving you a call?
No. I think he's just far too busy. But I really do admire his interest in the deep sea. I think that's fantastic, and also his interest in engineering the vehicle that went down to the trench. There was a deep sea biology meeting in New Zealand a couple of years ago where he talked to the band of scientists and told us about the engineering of the vehicle. Is fascinating stuff. Fantastic.
Where do you sort of see the funding going in science? I guess this is too broad of a question for you to answer fairly, but where do you see the funding going for science now with the new administration? Do you see the media helping and public interest growing in science, and that would help? What's sort of the solution, particularly in your field?
Well, many of us are very, very concerned about some of our new administration's views on whether or not climate change is even real. And that's horrifying to us, because we always think that attitude is always directed by self-interest instead of logic. So we're very, very concerned about that. We're very, very concerned about the potential for the new administration to shut down NASA or reduce NASA, because science needs satellites. We have to have, it's just like anything in life, you see it better when you step away from it. So our way of seeing the Earth is based on satellites. And if we lose our eyes in the sky, that would be a tremendous loss. So it's important that we stay very, very active and vigilant and vocal about what we think is important. As far as what I think is the most important thing and we'd like to see is a continued or even expanded interest in carbon as it goes into the sea. So that's basically our only chance of reducing or mitigating climate change is the sequestration of carbon in the ocean. And that only happens deep. It doesn't do any good to, sequester carbon in shallow water, because it just comes back out. So the only way to lock carbon away is in the deep ocean. So I believe that's the most important direction of funding, would be to keep studying carbon flux into the ocean. I think that's our biggest issue.
Okay, so I asked this in the wrong order, but number one, what's the best way for people to get engaged? So if you're listening to the podcast, there's many layers of getting involved, whether you just talk about this in the lunchroom, or you're a PhD grad and you want to go study something, or you want to donate, or you want to, what's the best way for people to get involved and learn more about this?
Well, for the public to get involved, it really is the onus is on us, the scientific community, to expand our outreach and expand our skill at outreach, because scientists are usually not that good at it. But it's something that, at least from the scientist point of view, telling the story, have just a clear point instead of, I've probably been babbling way on, so I'm a perfect example of the wrong way to do it. Basically have a clear, concise point, that people can appreciate. And then for the public, there's a lot of information out now. The most important thing I think the public can do is focus on good information. Don't use the internet for news. Stick with, respected newspapers and respected news outlets, and stop listening to everything you see on the internet. That's enormously important.
If they'd like to get involved to read more about Deep End and read more about your work and your publications, where can they find you?
The websites. We spend an enormous amount of effort making the website approachable and easy to get through, and then we have a news section on the website. So that's a great way to get in touch. There's also a new initiative out. It's an international initiative. It's called the Deep Ocean Stewardship Initiative, and their acronym is DOSI, DOSI. So people can Google DOSI. They handle all of these issues. They address all of these issues that are affecting the deep sea and our effect on the deep sea. So that's one of the really outstanding initiatives that's happening now.
Fantastic. Okay, very last question. Do you have a favorite creature?
Yeah.
That you've discovered? Or did you like?
Oh, a favorite creature? Yes. Yeah. There's a dragonfish that I'm particularly fond of. It doesn't have a common name per se. Scaleless black dragonfish, I guess is what it's called. It just seems to have a personality of its own. It has a face that looks like T-Rex. And when it opens its mouth, it's got rows of teeth that just keep going and going and going, all the way down into this road or whatever. And the species name is Echyostoma, Echiostoma. There's just one species in that genus. I've always been fascinated with that fish. That fish is going to be featured on Oceans, the new BBC. As kind of their follow-up to Blue Planet. Well, I think they're calling it Ocean. I don't think that's a secret now. You might be able to just Google that and see if they've even released that.
BBC just call you up. They're like, right,
we've taken them out filming on Deep End. So they brought one of their. I worked on Blue Planet, so I just love the BBC and how they go about their business. Their products are fantastic. So they called and asked if they could come out and do some filming on deep end cruises. So they sent somebody out with their super camera, and they said, okay, what are we going to get that's fantastic? And I said, this one dragonfish I just mentioned. So they got pictures of it that just jump out at the screen. I mean, we looked at it on the laptop out at sea, and we still took a step back. It was fantastic.
Yeah. Tell us a little bit about that, because I don't think we've spoken to anybody that's had BBC come out for them. What was the process like? What were they like to work with?
Well, they're fantastic generally because they care so much about accuracy and getting the story right first before they just start filming stuff. And they're super, super deliberate about how they film stuff. So I guess they had gotten my name because I worked on Blue Planet before when I was a grad student. I took them out and we filmed a lot of stuff for their deep sea episode on Blue Planet. Other than that, I'm not really sure why, but they just sent an email and we just started a chat. And after about 6 months, we kind of had a working plan, and then they sent their person out on cruises. Fantastic to work with. So yeah. And basically, I would work with anybody just to kind of get the word out about all this weird stuff that's down there.
Yeah, that's like I think BBC, I feel like, are the one kind of channel that are still pushing and fascinating kids and teenagers and adults alike.
Yes.
Somebody's always talking about it. When they released the trailer for Planet Earth 2 with the marine iguanas getting away from the snakes, that scene, that went viral and everyone was just amazed. It's almost as good as TV could get. I'm just really glad that that's still part of the conversation.
Yeah, me too.
Still part of the media. But while we were talking, I just Googled the scaleless black dragonfish. And I think that would make a great stuffed toy. If you ever go into merch, maybe one of those, so the kids can go to sleep at night would be beautiful.
Yeah. Oh, there you go.
Tracey Sutton, thank you so much for your time. I much appreciate it. And
you're welcome. I thoroughly enjoyed it. It's been fun chatting with you.
Thank you. Thank you very much. All right. Take care. I'll talk to you soon.
Okay. All right. You too. Bye-bye.
Well, that's all we have time for this week. Thank you for listening to the UNIVI podcast. To follow our series, please subscribe to our channel via iTunes, Beyond Pod, or the equivalent service. And if you particularly enjoyed the show, please don't forget to rate. For further information, news, videos, and articles, head to univ.com.au.